I'm Dr. Faezeh from Deakin University, and I'm here today to introduce our latest work, which was published in the Journal of Nature Materials. And the work was about introducing a novel materials which are called zwitterions with intrinsic disordered structure and plasticity that can be able to use as solid-state electrolyte in electrochemical devices.
So we've been interested as a group in developing plastic crystals and ionic liquids for a long time, particularly in terms of new batteries, and especially lithium metal and sodium batteries. We know that ionic liquids and plastic crystals can bring important properties like very low flammability and low volatility, which is really important for stability, especially when you're using something as reactive as lithium metal. So what we did with this new work in partnership with our industry partners Boron Molecular was, instead of having separate cations and anions that make up our plastic crystal, they're actually joined together by sort of a covalent bond. And so what that means is that then when you take that mixture of your quite disordered plastic zwitterion with some lithium salt in it and you put an electric field across it, which is kind of what happens in a battery, the zwitterion doesn't move. But the lithium is the one that moves most of all, and that's exactly what you want in a lithium battery, right? Because it's the lithium that's doing the work.
Hi, I'm Oliver Hutt, Director of Business Development here at Boron Molecular. We're a fine chemical manufacturer and have been collaborating with Jenny and her team for a number of years. It's been a really exciting opportunity for us to get involved in some new, exciting small molecule chemistry. And our role is really to make sure that the team has sufficient volumes of the material they need and scale-up capability so they can do the types of downstream testing they need to do on these materials.
In this work, we combined these novel zwitterionic plastic crystals with different concentration of lithium salts to be able to use them as electrolytes for lithium battery applications. So in this work, we selected three different approaches. One, we made solid-state matrix materials for battery applications, and in the second strategy, we made the composite materials by combining them with the functionalized lithium polymeric nanoparticles to enhance their mechanical stability and also increase their lithium ion transport number. And in the third strategy, we made high salt content, non-flammable, non-volatile liquid electrolytes. And all three electrolytes showed a good support of lithium metal cell cycling and also good lithium ion transport number.
Part of the excitement as well is that hopefully this is just the start of what's going to be maybe a whole family of new zwitterionic plastic crystals. So really a new materials class, I guess, is part of the excitement of this work.